Hello, welcome to all. Okay, today we will see the types of specific heats. Why there are two types of specific heats for any system or material. The reason is that in how many ways we can heat the systems. Here we may heat any system in two ways. That means you may pump the heat into the system in two ways to observe the same 1 degree rise in the temperature per 1 gram of the material. So obviously we have two types of specific heats. What are they? Let us consider specifically gaseous systems. Okay. In how many ways we may rise the temperature of any gas? That means in how many ways you can heat the gaseous systems? How many types of possibilities are there? There are two possibilities. One possibility is heating the system at constant pressure. Okay, this is one way of heating the system. Next, what is the other way of heating the system? Second one, heating the system, okay, the same system at constant volume. Okay, suppose that, see, these are the parameters of the gaseous system: pressure, volume and temperature. All of you know this. Now, here whenever we discuss about the specific heat, T, absolute temperature, is always a variable, but we may fix either pressure or volume of the system. Suppose that you are heating a gaseous system. You are heating a system, that means this is a cylinder in which the gas is bounded. See, I am taking the gas in this cylinder with the system. This is our system now. Now what we are doing is we are heating this system with some goods or whatever it is. So with some flame we are going to heat this system. See, now here you are heating this system at constant pressure. See, what is that constant pressure? Here you are heating this gas at the atmospheric pressure. The atmospheric pressure. Okay. Now, suppose that you are supplying some amount of heat Q to the system. Then what happens to the system? What happens to the system? See, here two things may happen. According to the first law of thermodynamics, two things may happen. One is, the system may utilize the given heat. What is the first law of thermodynamics? dQ is equal to du plus P dV. Okay, what is this? P dV, this is the dW. This is dW. Okay. See, according to the first law of thermodynamics, dQ is equal to du plus dW or pdV. Okay. Here, so whenever you supply some heat to the system, it may be divided into two parts. It can be utilized for the rise in its internal energy. U means internal energy. Okay. Next, the part of the given heat may also be utilized to do some external work. Okay. What type of external work is possible here? One is rise in internal energy, means internal energy is directly connected with the temperature. Rise in the internal energy means rise in the temperature of the gas. That is one possibility. Part of the energy part, you have to remember that only a part of the energy will go for this part. That means for the rise in the temperature of the system, and part of the heat given by you or the energy given by you is also going to be utilized to do some external work, to perform some external work. See what type of external work you expect here? Here, this gas may do some external work by pushing this piston upwards. Pushing this piston upwards. So, what you are going to see here is, suppose that now your piston is reached this position. So, what is happening here? Your system volume is changing from volume to the new volume. Okay. The volume of this space is V1. Now after the expansion of the gas, so the volume is going to be changed to V2. V2, okay. This is the volume of the new box where the top is the air dotted line. So here you have one point you have to observe is the entire heat given by U is not solely utilized for the rise in its temperature. So at the same time what happens, the heat, the temperature of the system also goes up, as well as at the same time it does some external work. So here you have to supply some heat unnecessarily to perform some external work. So here you are going to supply much amount of energy or heat to observe the 1 degree rise in the temperature. Why? Because there is some leakage in the form of the external work. Okay. Now let us go for the second case. What is that? Heating the system at constant volume. How is this possible? Here you see here. Now you see here. Here. Now this is your system. Here what I am doing is I am placing some weight, okay, or by other means I am increasing the friction between this wall and this piston so that it cannot move up or down. Okay, otherwise you put this weight, at the same time you have to see that it is not pressed downwards. See what is happening now is, now again you go on giving the heat to the system. What happens now? Here there is no scope for the expansion. Why? Because here you are placing some weights. That means you are heating the gas at the constant volume. At the constant volume. Okay? Constant volume. Right, here the pressure may increase inside, the pressure may vary inside. As you go on heating, the pressure varies. But here the volume is fixed. Here what happens is, see, whenever this there is no change in volume. Okay, see here there is no question of V2. All the time you goes on heating, you always find the initial volume only. That means in this case dV is equal to 0. In the second case, okay, what happens then for this dW? So in this case your dQ just becomes du. Why? Because P into this dV is 0. That means dQ is equal to du only. dQ is equal to du only. That means whatever the heat you are giving to the system is solely utilized for the rise in its internal energy. That means there is no leakage in the form of external work. So you will see the same 1 degree rise in the temperature immediately, okay, compared to the case of this heating the system at the constant pressure. So you are going to see the same 1 degree rise in the temperature a little bit earlier whenever you heat the system at a constant volume. See, suppose that you observe in this case 1 degree rise in the temperature for 1 gram of material. Okay, for say some Q is equal to some Q1 calories. But whenever you supply the same Q1 calories, in the first case, you will not be able to see the 1 degree of rise in the temperature for 1 gram of the gas Why? Why? Because part of the energy is utilized to perform this external work. To see the same 1 degree of rise in case of constant pressure, what you have to do? You have to supply some more energy. Okay. So more energy, more heat energy is needed for 1 degree rise in the temperature whenever you are heating the system at constant pressure. So you always find Cp is more than the Cv. That's why you see in case of an ideal gas, you always have Cp minus Cv is equal to R, which is a positive quantity. Why? Because Cp is always greater than Cv. So you have Cp minus Cv is equal to R, a positive quantity. Okay. Before ending this lecture, let us see what we have done so far. See, we discussed about why the system have some two different types of specific heat. Why? Because there are two different ways to heat the system. That's why we always have two types of specific heats. Okay, if C is a specific heat, you always have Cp as well as Cv. Right? That's why you have two different specific heats. Two different specific heats for the same system. What we have done next, we are also discussed why one type of specific heat is greater than the other type of specific heat. Why? The specific heat at constant pressure is greater than the specific heat at constant volume. Okay. What happens in case of constant volume? The system, there is no scope for the system to do the external work. So the entire heat given by you, the system is solely utilized for the rising temperature. So for small amount of heat energy only, you will see 1 degree rise in temperature for 1 gram material of the system. But that does not happen whenever you heat the system at constant pressure. There is always a scope for the rise in the temperature. So system definitely does some external work. Part of your energy is utilized to do some external work, even though which we do not need in this case. That's why you have to supply some more heat energy in order to observe the same 1 degree rise in temperature for the 1 gram of the material. So we always see Cp greater than as greater than the Cv. The Cp value, we always the Cp value greater than the Cv value, and the difference is always positive. Okay. So let us stop with this. Thank you.